So this is an exercise that illustrates what contouring is and what it means and how to do it. Contouring is obviously done like a lot of things. You can write computer code to do it very simply, but it's reasonable to understand basically how it works. So the idea here is that we have some sort of spatial array of data, and this could be the height of water in a well. This could be the concentration of contaminants in a well. This could be temperature on a surface. It could be anything you want to contour, right? So we have these discrete points, and when the eye looks at this, you can't make much sense of it. But by drawing in contour lines, and you remember what contour lines are, they're points, they're lines that connect points of equal value. A contour line on a topographic map connects points of equal elevation. By looking at those lines, you're able to your brain is able to make sense a little bit of something. So let's imagine that these are data points that define the height of water in the well in wells drilled in a big field, and we want to get a sense for what direction the water table is oriented, so that we know what direction the water might be flowing. And some of these terms I haven't necessarily defined yet, but we just want to get a sense for what the orientation of all this is. Okay, so the first thing we need to do is we need to define a contour interval, CI, and we'll make that 10. So let's say 10 feet. So what we're going to do is we're going to find values that are evenly divisible by 10, and we're going to contour them. So let's start in the upper left-hand corner here. We have 125 and 112. If you imagine a line that connects those 2 points, and I'm just kind of dashing it out here, what number evenly divisible by 10 lies between 125 and 112? Well, clearly it's 120. So if you assume that this is at 100, you know that this is at 125 and this is 112. So where would 120 be along that line? Halfway would be about 17 and a half. Is that right? About 19, 18, somewhere in there. So 120 would be right about here. That's about 120. Where else would 120 be? Would 120 be between 125 and 130? Nope. Would it be between 130 and 115? Yeah, it would be somewhere along that line, and it would be 1/3 of the distance between 115 and 130. So you can imagine going from 115, go 1/3 of the way, now you're at 120. Go another third of the way, you're at 125. Another third of the way, you're at 130. So 120 would be right here. Where else would it be? Would it be between 112 and 115? No. Between 112 and 110? No. Where would it be? Between 115 and 122? Be somewhere along this line, right? Halfway would be, so you could subtract them, that's 7. 122 minus 115 is 7, so half of 7 is 3.5. So if you add 3.5 to 115, that halfway is 118.5. So 120 would be somewhere about here. There's 120, there's 120. Where else would 120 be? Would it be between 122 and 110? Yeah, it would be. We can just kind of start doing this quickly. It'd be about there. I don't know what that's supposed to be. Let's call that 118. Would it be between 125 and 118? Yeah, it would be about here. Would it be anywhere else? I don't see anywhere else where it would be. So we could just sort of draw a line that connects all of those points, and that is the 120-foot contour. What about 130? Well, 130 is going to go through this point. It's going to go between 133 and 122, and we'd say maybe it's a little closer to 133 than 122, right? So it'd be about here. And between 140 and 125, it would be what would that be? 1/3 of the way there, right? 1/3 of the way between 140 and 125. That would be 130, 135, 140. So 130 would be about here. So we can sort of draw a line that goes like this. That is 130. 140, we'll just draw a parallel line there. So now we can do one for 110, for 90, for 80, and so forth, all the way down. And so what I'd like you to do now is complete the rest of this exercise on your own, and then I will post the key, and we'll compare and see how we did.